Hi students, problem number 17. In Young's double slit experiment, the two slits are 0.5 millimeter apart and the fringes are observed at 100 centimeter from the plane of the slits. The distance of the 11th braid fringe from the first fringe, is 9.72 millimeter. The wavelength of light has to be determined. Again, it is very easy problem. We have to write whatever quantities are given in the problem. So the two slits are 0.5 millimeter apart. So what is given here first? Small d. So this is equal to 0.5 into 10 power minus 3 meter. The screen is at 100 centimeter from the plane of the slits. So here capital D is equal to 100 centimeter, that is equal to 1 meter. Now the distance of the 11th braid fringe from the first fringe is given. So how many number of fringes will be there from the first up to the 11th? From the center of the screen up to the 11th means 11 fringes will be there. From the first fringe to the 11th fringe means only 10 fringes will be there. So my dear students, you have to understand carefully that the distance given is equal to 10 times the fringe width. 10 beta is given. So 10 beta is equal to 9.72 millimeter. So this is 9.72 into 10 power minus 3 meter. So from this lambda has to be determined. So I start from 10 beta, So 10 into lambda d by small d is equal to 9.72 into 10 power minus 3 meter. So what is lambda? Therefore, lambda is now equal to 9.72 into 10 power minus 3 into this small d is coming up divided by 10 capital D, 10 times capital D is coming down. Therefore, the wavelength of light is equal to 9.72 into 10 power minus 3 into small d. The small d is what? 0.5 into 10 power minus 3. So 0.5 into 10 power minus 3 whole divided by 10 into 1. So this is 10 into 1. So this is equal to 9.72 into 0.5 into here 10 power minus 3 into 10 power minus 3 is 10 power minus 6. So this is 10 power minus 6 into this 10 power is coming up as 10 power minus 1. So 9.72 into 0.5. 0.5 means what? 1 by 2. Half. So half of 9.72 is 4.86. So 4.86 into 10 power minus 7 meter. So this also can be expressed in centimeter. So this must be 4.86 into 10 power minus 5 into 10 power minus 2 meter. So minus 7 is split as minus 5 into minus 2. So this is now equal to 4.86 into 10 power minus 5 centimeter. I have expressed in the centimeter unit. So now you see that option A is the right answer. So the wavelength of light is 4.86 into 10 power minus 5 centimeter. These are all direct substitution problems only. Such problems are also many times repeatedly asked. I hope you must have understood this well. Fine.